Let's talk about increasing, decreasing, or constant functions now. So the first definition says a function f is increasing on an open interval I. Now it says open interval. If for any choice of x1 and x2 in I with x1 less than x2. So if x1 is less than x2, that means x1 is always on the left of x2 when we're thinking about this graphically. And then it says after that, we have f of x1 less than f of x2. Now, f of x1 is a y value. Hopefully you understand that. And f of x2 is also a y value. So what it's really saying here is the y value when I plug in x1 is smaller than the y value when I plug in x2. So let's take a look down here at the graph just to try to understand that a little bit. So let's say I take this value as my x1, and I take this value at the 0 here as my x2. And if I plug that in my function, that's going to be down here, and that y value is going to be negative down here, isn't it? Yeah. That's just going to be some negative value down here. So it looks like it's going to be about 1, 2, 3. So negative 3.5. That's going to be my y value. That's my f of x1. And then when I look at now my x2 is in there. I took the origin with that one. So then that's going to equal 0, and that's going to be my f of x2. So we can see that the y value when I plug in x1 is smaller than the y value when I plug in x2. So therefore, I can say, at least on that interval where x1 and x2 are, that it would be increasing. So that's the idea of this increasing. So I'm going to look at an x value on the left and an x value on the right, and taking those two values, I'm going to plug those into the function and see what's going on with those y values. And if f of x1 is smaller than f of x2, then I can say it's increasing. Okay, now let's take a look at decreasing. A function f is decreasing on an open interval I for any choice of x1 and x2 in I. And then it says with x1 less than x2. So it's the same instance as the first where my x1 is on the left, my x2 is on the right graphically. Okay, and then it says we have f of x1 greater than f of x2. So now this is saying when I plug in x1, my y value is now going to be larger than the y value when I plug in x2. Okay, so that's where we're heading to now. So that means if I took these two same values there, that wouldn't be true. Because remember, this was 3.5, negative 3.5. This was 0 for my y value. And my f of x1 is smaller than my f of x2, not bigger than. Now we need it to be bigger than. So that wouldn't work here. So what we're going to do is we'll take another piece of this interval. And honestly, you could tell if you have a graph by looking at it that it's increasing or decreasing. Because when I look at this point right here, that point is higher if I'm looking at the y values than this point down here. So this y value is larger than this y value. And this x1 is on the left, this x2 is on the right. So on the left, on the right, and it's decreasing because the y value here is larger than the y value here. And that's what we need here. Okay, so that would be decreasing. So honestly, we can really tell by looking at the graph, but I just wanted to run through the definition with you. Now the third one says a function f is constant on an open interval I for all choices of x in I where the values of f of x are equal. So if I take two values and it's constant or it's equal, then I could say it's constant. Okay, so if we look at this graph here, and let's say I take this value right here, call that my x1, and that would be 3. And then I take this value right here, that's 4, 5, 6. Okay, and I plug in my 3 and 6 into my function. For both of those, I'm going to get my f of 3 to equal 2 and my f of 6 to equal 2. Now keep in mind the 3 is on the left, the 6 is on the right, and that's the same for these two. Then it would be the same value. So if f, a function f, is a constant on an open interval I, if for all choices of x in I, the value f of x are equal. So we can see if I picked any value in here, that it would all result in the y value being 2. So I use that y value to evaluate if it's increasing, decreasing, or constant. The x value is there, of course, because that's where it's actually happening at, but it's the y value that evaluates it being increasing or decreasing. So let's get started with this problem to the right here. It says use the graph of the function to find. It says the interval or intervals on which the function is increasing. So remember, now we're going back to set builder notation, not set builder notation. Sorry about that. We're going to use interval notation here. Interval notation is a lot shorter, a lot less symbols, faster to write. Okay, so we're looking where our intervals are of the function are increasing. So just by looking at the graph, I can see that, hey, it's increasing here because my y values are going upward in an upward direction, right? And it's also happening here. Hopefully that's clear to you. So all I'm going to do now is I'm just going to look at those and say, hey, what are those x values? Because it's the x values we use to say, hey, where is this thing increasing at? That's going to be our way we measure. So if I kind of draw that line up there, I see it's going to happen here all the way to here. Oops. Here. To here. And that whole interval there, from that x value of -3 all the way to 2 is going to be the interval where it is increasing. So I don't include the n values here because at the n values, at this point here, it's not actually increasing or decreasing. So I would just use a parenthesis for that. So I would say -3 to 2. And that's one interval. Now also we see that it's going on this end too. So that's going to be 3, 4, 5, 6, 7. So that's going to be at 7. And it looks like it goes in an upward direction, but also it's tilting to the right there. So that tells me it's going to also continue right. So that's going to be, and I would just use a comma here, just because I'm listing the intervals, so to speak. So that's going to be from 7 to infinity. So that's going to be my interval notation for the increasing parts of this function. Now let's look at where this function is decreasing at. So we can see that it's decreasing on this piece of the graph here, and I think that's all. Yeah, there's nowhere else when I go from left to right that it's actually dropping my y values. Okay, so that would be the only piece right there. So if I drop it down to there, it looks like it's an 8, or very close to the 8. And it'd be actually not 8, but -8. And then it goes all the way down to that 3 that we had earlier, so -3 there. So it's going to be from -8 to 3. Oops, -3. So there it is. So now the intervals in which it's constant. And there we can see that it's going to be from 2 to 7. Because look at when I plug in f of 2, that's going to be 2. When I plug in 2, I mean for x, I get 2 for f of x. Yep. And that's going to be all the way to 7. So I would say from 2 to 7. And I can actually include those n values because it is also going to give me 2. So that's the end of this problem.